Okay. Great. Guys, what I want to do next, if you don't mind, we'll kind of move on from the pigeonhole principle and come back to the permutations and combinations. I just want to warm up a little bit with some more practice on combinations. You know, we did a series of poker hand examples on Tuesday, but of course there's lots of other examples that we could use. So I thought we might just do a few warm-ups here. And I just really like these problems. It's just kind of fun to think about these things. So let's do some examples to warm up with, just to kind of get the juices flowing. So here's the first warm-up problem for today. Let's say that we have a group. So from a group of 6 men and 8 women. Okay, so I'm going to have a group of people here. What I want to do is how many ways are there to form a committee of 6 members? Okay, so I have 6 men, 8 women. How many ways are there to form a committee of 6 people if, and of course, I'm going to give you a few constraints. The first one is all committee, so part A, all committee members are the same sex. So we have all guys or all gals on our committee. Okay, so we'll start off with that one and then we'll work our way up from there. Give you a second to think this through. So we have to think about questions about is repetition of objects allowed? Well, probably not, because we've got 14 different people here. And does the order matter? Well, when we're forming a committee, it doesn't say we're putting them in order. It just says we're taking a group of people. So we have to think about the fact that for a committee, the order probably doesn't matter. So this is just like the poker hand, where you have no repetition of the cards in the deck, and it doesn't matter what order you play them in, right? Same thing here. It doesn't matter what order you pick the committee members, and there's no repeats. There's no repeats. So what do you think? Do we have some thoughts about how to come up with an answer, Jose?
We just split about like 2 cases, right?
Okay, you can have an all-male committee or an all-female committee, which actually creates cases. So interestingly, we're going to have the sum rule or the addition principle combined with combinations here, right? So for the solution, that's exactly right, Jose. Very good. So for the solution, we can have 2 cases. So case one would be all males. How many committees could we make that would have all males on them?
1.
There's only one way to do it, because your committee is supposed to have 6 members and you've only got 6 males. So it's really just 6 choose 6, if you want to write it that way, which is just 1. And then case 2. So I'm using our choose notation from Tuesday pretty liberally here already. We could have a committee that would be all females. And how many of those would there be?
8 choose 6.
That's 8 choose 6. We have 8 females, we choose 6 of them. And so then by the addition principle, there are 6 choose 6 plus 8 choose 6, which is actually very easy to calculate that. That's 29 committees. 6 choose 6 is just 1. And 8 choose 6 is 28. So yeah, that's the answer. This is about kind of how I would want the write-up to be. Part of why I'm doing these examples too is to just illustrate kind of how to express the answer. So I like the breakdown of cases. And I like sort of spelling out each case and then adding them together, right? Instead of, you don't wanna just give me the answer. That won't get you very far because I won't understand where it came from necessarily. Okay, sweet. Anybody have any question on that? Let's do a second part here, just to kind of, again, these are just kind of to get us warmed up today. The second one is part B. Part B is going to be that the committee has more men than women. The committee has more men than women. It's another question, just to kind of play with the same setup here. What's a good way to analyze that, do you think? Somebody else?
You'd have to do cases, right?
Maybe cases again? What kind of cases would you be thinking about?
You could have one more man, two more men. Three women.
It needs to be a committee of 6 members, so.
Yeah.
We can actually spell out how many men and
Yeah,
women
yeah.
would the cases be, right? So I would probably think of it in that manner, but it's definitely cases. It's definitely cases, so, you could have case 1 could be. Well, it could be 6 men again, right? So all men. And how many committees would there be with all men?
One.
Same thing we had before, 6, 2, 6, which is 1, right? And then case 2 might be. What would be a second case?
5 men, 1.
5 men and 1 woman. Okay, and for that one, how many choices would there be?
6 choose 5.
6 choose 5 to choose the men, and then
8 choose.
8 choose 1 to choose 1 woman, exactly, and we use the multiplication principle on that little subtask because you've got 2 subtasks in building the entire committee. Okay, and this one, we actually have a third case, right?
Yep.
And that would be 4 men and 2 women. And so this time, what are we gonna end up with here?
6 choose 2. 8 choose 2.
Great, 6 choose 4, and then multiplying that by 8 choose 2. Remember, all of these are numbers, but I would not need you to calculate these numbers necessarily if it was on a test. You could just leave it unsimplified. It's actually better to have it unsimplified. So I can see where the terms are coming from. And so by the addition principle. We get. Just have to add all of this together, 6 choose 6 plus 6 choose 5 times 8 choose 1. And then 6 choose 4 times 8 choose 2. We could work that out. Or we could not. 6 choose 6 is 1. 6 choose 5 is 6 times 8, that's 48. And 6 choose 4, how do I do these in my head? It's basically 6 choose 4, I know it's the same as 6 choose 2. And I just do that thing where I start factorialing down from 6 as far up as it takes to get to 2. So 6 times 5 divided by 2, which is actually 15. 8 choose 2 is 28 because 8 times 7 divided by 1 times 2. And that's going to be 420 plus another 49, 469. I think I have that right. The actual number doesn't matter that much, but. Yeah, that's basically it. Okay. Great. Let me give you one more, part C. Part C is simply. The committee. Must. Choose. A president. So. It's not just 6 people randomly. There's actually one of those 6 people that's on the committee that is sort of the leader or the president of that committee. See if we can think about how to do that. Does anybody have any thought about how we could do that?
Any conditions on what the president has to be, or it
No,
could be anyone?
it could be a male, a female, yeah, any of the 14 people, actually. Kevin? Okay, start by just choosing a president from the whole entire group of all the people. I like that, so choose a president first. Okay, and you're right, I think that sounds good. 14 choose one ways to do that. Once I've chosen the president, then what else do I have to do? Choose everybody else, and how many choices would that be? 5, exactly, 13 choose 5, so then choose the rest. And that would be 13 choose 5, what am I gonna do with these 2 numbers? Multiply, multiply, yeah, it's the multiplication principle, because these are 2 subtasks of this, of the whole thing, so. There are 14 choose 1 times 13 choose 5 ways. I'm wondering, could anybody think of a different way to get the answer? Yes, remind me one more time, is it
Sergio,
Sergio? I knew it started with an F. Okay, go ahead.
you choose the committee first and then you pick someone in the committee to be president.
Okay, an alternate solution is to first make the whole committee, that would be 14 people that I would choose 6 of those. I'm not worrying about whether they're males or females, doesn't matter. So I just choose all 6 of those, and then from those 6, I would choose 1. So here I'm choosing the committee first. Choose the committee first, and then here, I'm choosing the president, from that subset that made up the committee. So, by the way, in case you're wondering, that proves that this number is equal to this number. Because you counted the same thing in 2 different ways. We're gonna discuss this in a lot more detail later, that you can actually prove interesting identities involving combinatorial expressions by doing this kind of a reasoning. Find some phenomenon to count the arrangements for and count them in 2 different ways. Each of those 2 ways has to ultimately lead you to the same answer, so you know they're the same for that reason, actually. It's kind of interesting. Here, you wouldn't need that, of course, you could just use a calculator, see that they're the same, but more generally, we can prove combinatorial identities with this kind of do a solution one way and then give an alternate solution the other way. They have to be the same because you're counting the same thing. That's kind of nice, kind of a nice way to do things. Okay, let's try another one. I'm gonna change gears with a slightly different topic here. Well, I'm still gonna take 6 men and 8 women, but now I'm gonna put them in a bunch of chairs. And see how many ways we can do this. So let's do, I'll call this number 2 for our warm-up list here. How many ways are there to seat 6 men and 8 women in a row if no men can sit next to each other? So 2 men are not allowed to sit next to each other, and we're trying to put these 14 people in a line, basically set them into a line. So anytime I have two men, there has to be a woman in between them. Fourteen chairs sitting there. Probably what I would think of first would be to do that. Once we have figured out which chairs the men will occupy and which chairs the women would occupy, that could be thought of as a task. I could say, okay, we got these 14 seats, make sure that 8 of them are gonna have women in them and 6 of them are gonna have men in them. Once we've done that, it'll be pretty easy to count how many ways to put the 8 women into the 8 chairs and how many ways to put the 6 men into the 6 chairs, right? Once we've figured out which chairs go with who. But we can't put 2 men together. That's kind of the problem. So we could, if we wanted, what we could do is we could imagine, this is a little tricky, actually. Do you have an idea?
No.
Oh, okay.
No, I was agreeing with you that, yeah, it doesn't tricky.
It is a little bit tricky. What I'm going to imagine that we do is that we actually, this is actually not gonna turn out to be very helpful. Even though that's the natural thing to start from. You have an idea?
Could you like glue a men and woman together? Cause they have to, a man always has to be next to a woman.
Is it, but could we have 3 women together,
Yeah,
all
you could.
together, in which case
But
you
you would
would,
have those leftover women.
'Cause you've
So
got some extra
6 of the
women.
men will be glued, then the other 2 women will be left over.
yeah, it's a thought, you'd have to be careful about, are you gluing the man on the left side or the right side? Cause if you had. Like if in this gluing, you had the woman on the left and the man on the right, and then on this one, you had the man on the left and the woman on the right, then you've got 2 men next to each other, so you'd have to be
Yeah.
careful about that. I'm not gonna say that it's totally not going to be doable that way, but I'm gonna show you something a little slicker in a second. Was I?
Can we like first find out like the total, like ways to seat them and then subtract the violation?
You always can do that. You can always say, I'm just gonna imagine there's no rules and just do the big universal total and subtract violations. But it would really only be useful if the violations were easier to count. In this case, violations are also kind of tricky. A violation would just be a seating with 2 men together, but it might not just be 2 men. It might be 3 men or 4 men, or you could have all 6 men sitting right together. And you've got to be careful to only count each violation one time. It gets a little bit murky, you see. So, once I explain to you the way to think about it, you'll be like, oh, of course, that's so natural and it makes good sense. So maybe I should just do that, put you out of your misery, because yeah, these are all good ideas. And I like everything all of you are saying, but I'm just not sure that I quite see how to totally finish the problem. What we can certainly do is we could, instead of having the 14 chairs sitting out in front of us, let's just take all of the women out and set them into 8 chairs. So that there's only 8 chairs. I'm gonna label the women W1 through W8. And of course, there's going to be, by the way, how many ways will there be to put the 8 women into these 8 chairs? 8 factorial, right? First chair, there's 8 women that could sit there. The second chair, there's 7 women that could sit there. The third chair, there's 6 women that could sit there. So I'm just gonna mention here, there's 8 factorial ways to order the women in their chairs. So once you've decided which chairs they're going to be, you would have that many ways of actually putting them in order. So that's actually a permutation. There's no combination there. That's actually a permutation. But anyway, let's just set out these 8 chairs for the women, right? And now the men, there's 6 of those, have to come in and sit not next to each other. So there are gaps. There are some gaps in here. I'm gonna make little slots between where the women are sitting and including on the end. And those, how many gaps did I make there? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And the point here is that two men cannot sit in the same gap. Right? Because if I put two men right in here, then they're next to each other. Right? So these are actually slots that are set up between the women's chairs. Right? So what do we have to do in terms of getting 6 men to occupy spaces that I've labeled there with those slots?
Nine choose.
9, choose 6 ways to choose which of the gaps are the men gonna actually use, right? So maybe the first man will be there, and the second man will be there, the third man will be there, the fourth man will be there, maybe there's a gap here, the fifth man will be there, and the sixth man would be here. This is just one example of how that might look. Right? So there are 9 choose, let me just add that here. There are 9 choose 6. So you see how combinations and permutations are showing up together in the same problem. There are 9 choose 6 ways to choose. Let me give myself a little more room. I'll write this up a little bit higher so it's easier to see it. To choose 6 spaces to put a man. So you choose the spaces that the men will sit in, and that means that you won't have any men in the other spaces. And then what else do we then have to choose?
The permutation of them.
We have to permute which man goes in which of the 6 spots, right? So just like with the women, now there's going to be 6 factorial ways to order the men in their chairs. That's exactly right. Does this make sense? So the 8 factorial is permuting the women. The 6 factorial is the permuting of the men. The hard part is, how do we make sure that we don't have 2 men next to each other? Well, we create gaps between the women and we allow only 1 man to fill any one of those gaps. And so there's 9 gaps and we just need to choose 6 of those. And so then finally, by the multiplication principle, and again, you have to kind of write this out as a paragraph. The total number of ways, or I'll just say the total is 8 factorial times 9 choose 6 times 6 factorial. Okay? That would be it. If you think of another way to do it, let me know. That's kind of the way that I kind of came up with it. Okay. But that idea about subtracting violations, so that is a good one. It's just in this case, the violations are just as hard as just counting the original problem, at least in my my point of view. So, questions? Okay, I'm having a lot of fun with this. I brought another group work. This time, this is not the divisional principle. These are combinations, permutations. Some of these are gonna be handled best using the subtraction trick, right? Some of them might have more than one way to think about them. Let me pass this out and we'll, now that we've kind of got our brains churning on these combinations a little bit, I'm gonna let you guys partner up. Again, you can partner with the same people or different people, it doesn't really matter. But I'll give you a little bit of time to talk about these problems. Whoops. There you go. You're welcome. Come on down, guys. This one I actually got to type it. My printer working again. Oh my gosh, I hate that. Right now, I'm not real happy with how the building is working. I know, I hate it. I do hate it for sure. Yeah. I tell people my office is.
Let's see if I remember the spell still, is that right?
Yeah, exactly.
Sergio, what's your last one?
Hidalgo. No, he's.
Oh, Till.
Hidalgo.
Marcus?
How many
Yeah.
strings?
See, okay.
Letters of the alphabet.
I got you.
So it's not about.
Yeah.
I-O-U.
You're
Five out. Yes.
And then go again.
No, that's one, the first one I guess to be the action principle, because we're gonna use the dates for.
So.
Oh, I,
I think it's a Disney movie. That's a cool name. Hidalgo.
oh yeah, the horse things.
Yeah, I've seen
One
that.
minus, yeah.
You know that, that's,
Right?
A little bit.
it's a horse. That's what it is?
One minus.
It's a movie about a horse?
Yeah, yeah, the horse is there. Oh, no, because, ordering does matter because you're,
Yeah.
creating streams.
Yes, we're creating streams, so order matters.
Yeah.
So it's permutations. So we have,
Yeah, exactly.
we have 26 to 7.
No, sorry.
26 to 7.
We're overthinking it, right? We have
7
one.
o'clock. Yeah. 26, 25, or 24, 6 by 26.
No,
Only 26.
no, it's not falling, so, well, that's when he gave the hint. Wait, hold on. Wait, but this is when he gave the hint about, wait, hold on. Wait, oh, the thing letters, okay, no, you're right.
Yeah,
It's better.
26 and 25 and 24.
Okay.
Yeah.
And then we subtract any words that have no vowels, which is going to be, how much vowels are there? We're counting Y as a vowel?
No, no.
Sometimes Y.
I know, that's why. They're only gonna have 5. Yeah. So why do you only have 6 slots there?
Did we discount? That's the hardest part.
It might be, and then.
Well, now we gotta subtract. If there's 5 vowels, it means there's only 21 possible. So it's gonna be 21 times 20 times 20.
I don't think it is one. This would be 1 minus number.
Yeah.
So if we had, if, oh.
You mean like this?
Oh,
Yeah, you didn't hear a
Oh,
lot.
okay.
You're kind of almost thinking of it.
Yeah.
So you just want to calculate it as an actual. We're allowed to repeat the same letter.
Oh, yeah.
So, yeah, that doesn't.
Okay, I did question 0, but I don't know.
Or string.
This is-
Of letters makes a difference. It's not the same as C. So this is actually going to need to be a permutation, where you do keep track of one.
Okay.
Rather
And
than.
then it would be
But you're getting closer.
Okay.
26 and 19 back.
Oh.
This would be 7 back.
I like it.
So that's not.
This is what we got.
But it'll be also multiplied by 7 factorial.
What are we-
That's how it works. You get 26 minus 7.
Yeah.
So this doesn't seem like it's not that. It's easily canceled.
You know,
Yeah.
say I like to do it.
Yeah.
Longhand, the way you're doing.
This A
So
part,
this is-
when it's Taurus, and it's just, it's
Another way of thinking about it is like, we chose the 7 letters to use.
This,
and
but
we
then this one should just be.
You're saying that 26 times 25 times 24 times 23 times 22.
Well, no, it was just that this is 26 factorial, but you kind of were already jumping straight into the.
Yeah, it's
This
just.
one should just be the same kind of thing.
This one is exactly one.
Okay, 21 times 14. We're in 16.
So there's what if we just.
Exactly one vowel means we have 5 piercings. So we pick the vowel first.
Yeah.
Yeah.
And then for the remaining letters, we would only have 20 remaining, or 21 remaining left. Yeah.
So we can arrange.
So we have 5, yeah, we picked one of them, so there's 5 possibilities. We put it in one of the spots. Yeah, it should be 1, it should be 5, yeah.
I'll let you go on to the next part. Good job, good job.
Yeah, this, I don't think this is factorial, though, this is 5.
Anybody need help?
Yeah, that's why I'm not sure about this.
Wait,
I don't think it's,
So this is 12, right? Never subtracting.
Vivian?
is it 7 factorial?
Yeah, we take the 7 that we're gonna use. Yeah, we arrange.
We're saying-
Yeah, it's like-
No, it hasn't been confirmed.
No, that's so. We definitely have to pick one of the.
Well, we got-
5, 2, 4, 5.
Pick,
No, take position.
Yeah, pick position. There's 7 positions.
Like we're like this. And then
And then.
The remaining 6 positions.
You do the seven factorial here.
6 positions. Yeah, at least 2 vowels in cases. We have to in case we have 2 vowels, 3 vowels, 4 vowels, or 5 vowels.
Or no, or you can do complement, where you subtract.
Subtract if you have 0 or 1.
Yep. Oh, actually, then we use part A and part B.
Yes. This is no vowel, so we take away that.
Yes.
This is one vowel, yeah.
Yeah. Got it. Yeah.
So you're gonna need to put this on.
Let's say you just subtract two. So totally pick up like no problem.
Wait, that's exact, at least 2.
Yeah. Yeah, at least two. So subtract this one and subtract this no.
It's like.
Yep.
Oh,
Yeah.
mine.
Which is what you.
No.
And
This is-
one.
But it's not necessarily one of the same.
Yeah. From Vietnam, how about you?
Right.
Wait, no, I-
Yeah.
I'm from America. So I don't know, somebody.
Oh, because we call it.
Oh.
That's from.
Oh, good one.
City.
That's fine.
Oh, yeah, what city is it?
Oh, yes, Saigon.
I know, sorry, that's the only one I know.
But the order
Yeah.
doesn't matter. I had ever speak there.
I just know about that.
So,
Wait, what's the capital of Vietnam?
Saigon. Oh,
I know that one too. I know that one too.
we don't have a few.
I know the name of it, but
Oh, yeah. Yeah.
I thought they would make it Saigon because they call it Ho Chi Minh City.
Yeah.
And yes, I thought they would make it the capital if they named it after Ho Chi Minh.
Oh.
yeah.
You know, this fake name, right, is usable. What do you have?
Yeah.
Still be like.
But that's not, that's
Still
all.
be
Oh, no, that's a whole.
That was, oh, you was at the.
27. From there, like, also, yeah, I'm ready to quickly.
Visit later.
You're right. Where's the thing that we compare
Yeah.
it to the winter and the summer here with Vietnam. Wait, and Marathon.
Yeah.
6 students need to find it.
The last
Just gonna try.
But if we over here.
This is a part A. That's a part A.
Yeah, so it would be,
That's exactly the idea.
oh, the 7 positions.
Yeah,
The
so.
7 ones will take the vowel.
So 7 times. I
I
hope that I don't find any for the, I didn't see the photo.
Pretty much.
Yeah, we're, I mean.
Okay,
like,
excellent, excellent. Looking good. Good job.
So this is.
This feels just like 10 choose six. Yeah.
Five.
Alright.
No, it's just like either,
Yeah, it says at most one, so they can't have more than.
they can't have more than that, yeah.
Yeah.
So it's just kind of like, we have like 10 blocks. You pick
They
the
never doesn't matter.
yeah, I don't think order matters.
Although,
You're
back
choosing.
the pairs are.
Oh.
Cause like, if I was advising Joe, and certainly me advising Marcus, so maybe it wouldn't matter. It would probably-
Yeah,
So we,
then it would just be times
it
6
would be
factorial.
10, choose 6.
Times 6 factorial.
Yeah, 6 factorial. Because, yeah,
Yeah.
there's gonna be different pairs.
No, because they can be.
Oh, that's right. That's right, 'cause it's increasing times
Would be 10 factorial or 6 factorial? It'd be 6, right? Because there's 6 students.
6 factorial.
Yeah,
Yeah,
it'd be 6, only 6 students can do it. Yeah.
yeah, because here we're picking the advisor and then we're.
So once the 10 advisors, once we get the 6 students, we can change around. Second student.
This one.
This one.
Yeah, yeah, yeah.
How?
all
Yeah, I think that's right. We can, if it comes by, we can,
Mine.
oh, this is 2A.
Yeah.
No,
No.
vowels.
Put a box right there. Keep it out.
Two, and so this is, exactly.
Anybody need help?
Stick to the 10.
Can we check an answer?
We can check an answer too.
2A,
That's looking really good.
2A.
2A, we're not 2A, 6 students need an advisor. Each advisor can take at most one student. And there's 10 advisors.
Yes, it is.
Exactly one, which we didn't.
Oh, yeah. So that's actually, if I really think about it, I'm sorry, I have to, when the 10 choose 6 is really this. And then you're multiplying it by 6
So it's
factorial.
10, yeah, 10.
Yeah.
So you're actually getting 10, 9, 8, 7, 6, 5. So the first student has 10 advisors to choose. Then the second student would have 9 advisors left. The third student would have 8 advisors left. Now, is that counting what you want to count?
I think so.
Each advisor can take at most one student. So yes, the first
But I guess if you
student
got
has
that
10
right.
choices for their advisor.
So we just wrote it along.
That's okay. I actually just need it for myself to confirm it was the same answer as mine.
Yeah.
Yeah, it looks great. It looks great. Yeah. So,
Yeah, it's much.
so
easier.
what you're doing here is you're saying, I'm gonna take advisors. Only 6 of them will actually take this.
And then
So you choose the
student that matters. So you permit it.
You just permutation from there. Yeah, that's a good way to think about
One student.
it. I like it. I like it.
Yeah.
Good job.
I like that.
Listen, when I look at this thing.
Good job. Yeah, this looks really good.
Oh, and then this gives us a hint for.
You can go on to number 2.
Yeah, so then it's 10, 10, 10.
Anybody need help?
Oh, yeah.
Yeah, yeah.
10 to the 6, right?
This didn't hit 10 joy to pick up my, yeah, but back yourself, I don't know.
Oh,
that's
fine.
fine.
Okay, well, they gave us the hint, yeah.
Okay.
Oh, and here's your.
Oh, God.
The picture in the back.
Oh, but at least he said in a row. He
Oh,
was specific about the arrangement. But there's no arrangement, you can do whatever in the picture. That's how I feel about it.
You just say, just hold it. Right? And then you're subtracting this one.
So we permute where the bride is at. And then we have, yeah, so we just gotta permute where she's at. So because there's 10 people, or no, sorry, 6 to 10, we're gonna do 9 to 15. And permute where we put.
Yeah.
We also have to permute where we put the other people.
Yeah.
So it's gonna be 9 to 6 times the.
Yeah, that's
There's 6 slots for the bride, so 6 factorial. And then the people can also be permitted in the files.
Yeah, just 6 though.
Yeah, 6.
Yeah.
Yeah.
Number 2?
Yeah, you give us the.
Yeah, each student has to,
Yeah.
I mean, you'll be surprised how many times people will give me 6 to 10.
Uh,
Or, you know, 10 to 6 or something like that. There's all kinds of ways of putting a 6 and a 10 into some kind of a common type of notation. So keep practicing that. Yeah, but you got it absolutely right. Looks really good.
Yeah. First we need to pick one of the bride, and then it doesn't matter.
yeah, there's 6 slots, right?
Yeah.
So there's 6.
And then, we need to choose.
Nine others from 1 hour to that. We give you fine, keep 6.
Versus 2 has all
These.
I always go up to, you know.
5, and then.
So then there's 60 on for being 6 in the group. One of them. Yeah, you just making good at 2 there.
Yeah.
One person, so those are slightly, we have 8 people now.
Oh, yeah.
So it's on round 2, 4.
Yeah.
We're gonna go 1 and 5.
Oh, but that's.
6 should do that. Yeah.
Oh, no, only baseball. Oh, no, we just take the 2 spots, but then.
Picking the 2.
Oh, so then. There you go.
That is.
Oh, yeah, yeah.
So now every professor is unlimited. And so you got your 6 students.
Oh, so I guess really,
They can all
Just accept
have
it.
whatever they want.
technically, it's the same. I think this is-
The professor can pick any number of students, the student.
Oh, yeah.
Permute, Brian.
Always, one person she talked about.
Choose what they are, then we can follow.
If I'm the professor, I could see no students, or I could choose several of you, and we can. What I did, that affects the next professor.
So is it the,
Now
you take the bride, you see, put her somewhere.
The second professor, I've already chosen one for you, and the second professor, will only have. Now you got all the. That's kind of. But it's a lot.
I think I have the same age, I think I'm just, think about it.
I think that's why we wrote it here, to maybe kind of different thought. We're just choosing the 2 spots, but then we do the arrangement. It's kind of like how we pick the first thing.
Yeah, I think we're saying.
So that's why I just had it sit here for like, even though it disappears, like, might as well have it. Yeah.
So.
Because 10 choose 6 is.
Oh, yeah.
So you don't need the.
So now the bride must stand next to them, because they're kind of grouped together.
Yeah.
That's like a block.
And that makes it easier to compare with part B, where the only
So,
difference is instead
in fact, we have
of
five.
middle,
Fine.
Yeah, they're go together, we're gonna have,
no, so your answer is 10 to 6.
they move together.
No.
Oh, so-
Because they are sick to it. So yeah.
See, see, answer.
No, fine. It's relative.
Is that what I used to want?
Like, there's all kinds of different.
The bride and bride, but not all stick together. So this means like you have.
But, yeah, I guess what I'm saying you have 4 slots remaining.
Oh, yeah, four slots.
That's what, because once you have the bride and groom, you'll have.
Yeah, so I think that's what it means, it's like we choose one of the 5 slots, and then we still have the accuracy. And then the remaining 4, and then we'll arrange it.
Yes.
Like, okay.
Okay, this one.
The bride is positioned somewhere to the left.
Then we have
They don't have to be stuck together.
Oh, no. Oh, somewhere to the left. Yeah. So we know the man can't, the bride is in the left, the groom, so the groom can't be in the very left.
Yeah.
Oh, wait, no.
Oh, so it has 5 spots.
The groom only has 5.
They work with the bride, so we're gonna be placed in between your legs for how many spots available.
Place.
Okay, we got, I guess maybe we have to.
Well, there's only 2 spots. Now we're gonna do. Oh, yeah. The guy had.
Only 9.
The guy would be.
Seven, that's 6.
If the groom's here, she's there. Groom's here, she's there. Or somewhere to the left. She could be in the 5 spots. Oh, yeah. So you're not next to each other.
If you like a case system, you don't have to, but
I see. The bride is positioned kind of like. I think we start with choosing what the groom's at.
Yeah.
that's fine.
Yeah.
Five.
Like, really one spot.
To like send on the water.
Yeah.
Yeah, but we want everything like. Oh, I realize the law.
Not necessarily.
Oh, well, so starting from the right, if the room is here,
And he has 5 plus.
4 plus 4 when you keep.
Wait, so that's 5 plus 4 plus 3 plus 8 plus 1.
Yeah.
So you're looking for the.
So I'm gonna, yeah, 5 plus 1. These are all mutually exclusive, and then.
There is a.
So we can place the groom.
We also gotta remember we put the groom is also 5 places for him.
Oh, no, but that's factored here, right? 'Cause each case where he was, because it's multiplying, right? So we place-
No matter what.
Also, they would. And I would. And choose.
And then they have 3.
Yeah.
Right.
Yeah, I think we-
They don't stick standard.
That's what I'm thinking.
What's
Wait,
the
wait.
difference?
Oh, this
But this-
Oh, you can see. Oh, wait, no, it's, no, but no, wait, it's like, wait, it's flip the other one, right? So you can see the right here, yeah. 5 choices. The bride's here 4, right? It's just a flip of the other one. So, but there, it's just the fact that it's, regardless of how we did it, like either the bride first, it's still, each case was independent, and there was still like starting with the bride, 5 places. Yeah.
The 4K, you think they want. Okay, so the.
It may not be wrong, but
Right,
it's not-
here, so you have 1, 2, 3, 4, 5, 5. And 6. So this.
Wait, are you saying that, yeah. There's something about the ODP, yeah. It's not. I feel like this is.
Somehow we already started confusing.
Oh, well, as long as this is less than this. Well, that's babies. Yeah.
No, they're both.
Oh, wait, that's 965. Oh, 30. Okay, cool. Yeah.
Okay, I kind of like it like.
Oh, wait, that makes sense because the other half is when the green is to the right.
Yeah.
Oh, that makes perfect sense. That is kind of cute, actually.
Yeah. Yeah, that makes sense. Now I like the answer.
So now we're satisfied.
And then we got them all, but how many
Okay.
courses that? It's like,
You can, and then there's a subtle point you gotta be careful about. Well,
This is our D. I think this is our D.
Right is somewhere left of the. Okay, where is B? B is here. Is that a substitute?
622 times 2 is for better.
I point out that 622 is actually 15. And times 2 is 30.
Yeah.
30, right? That was what I was saying.
Yeah. We, our mind is blown, we like it.
If all of the photographs that have both the right and by symmetry of it, half of the right to the left of the group. So this is 30 and this is 15,
Yeah.
and they both have the 8-2 score.
Yeah, we realized because we were doing a sandwich, like, okay, well, for sure this has to be less than that. And then-
Yeah,
And we realized.
and not just less, but actually half.
We saw that it was double that.
Yeah, that's not just a coincidence. That's not just a
It
coincidence.
makes sense, yeah.
Yeah.
You're to the left, you're to the right.
Yeah.
I was not happy with the answer until we put on that.
Okay. Well, super. Well, if you guys are feeling comfortable, we're about out of time. We've got a lot of active learning
You want to
today.
raise it?
If you've got 2 minutes to do it for me, otherwise I'm happy to do it. Maybe the big one.
Yeah.
All right. Let's see, you guys coming along pretty well.
How many ways?
You said it?
I think so.
Pride in the picture.
See, this is part of the reason why I want to stay in the class and not want to drop it because like,
You know,
this is more exciting.
I mean, you like something like that. This like.
Let me put it this way, during my summer class at night,
The rest of the.
at least 2 or 3 times, the professor's like, all right, I'm letting you guys just work on it by yourselves for like an hour. And literally none of us did anything. It was just a nice excitement. Yeah.
Oh, half of you still sit there and then
Right.
remember you still looking at the problem. Oh my God, it could be like for the class.
Oh, I was so glad that for the last lesson, because you know how we take pictures and put them in the OneNote.
Yeah.
Yeah, the last work I did showed up.
Yeah, you're right. What happened? What you were down?
Okay.
Yeah.
What usually people do is they TV. They use
I don't know.
Yes, but. No, we actually said.
Yeah, I'm putting the little writing on them.
Hey, guys, great job. Whenever you're ready to take off, you're welcome to do that. Solutions to this are on Canvas, so check them out. But we're pretty much good to go for today. I'm gonna head out for the fire drill in a few minutes, and then I'll be back to my office and in Zoom shortly. So if you got questions, let me know. See you soon.
But I.
Yeah.
I have class that starts at 5:30. I don't know if the instructor can actually. Bayesian statistics. Right next door.
But yeah, that would be like for women and
Yeah, but then at the same time, it's like a lot of people on Zoom are gonna be like, oh, where's the professor? Like, or like they'll message on Discord, like, oh, I'm trying to log on, or like, I don't know, yeah, we'll see.
I go to the thing this night tomorrow. Very fun, so you might edit to discuss a very good.
And then Dr. Martinez kind of does those kind of too, right?
Yeah.
Yeah.
When I'm studying for Dr. C for
Oh, the same is for Dr. C.
yeah, Dr. C, yeah, for the 581.
Yeah.
I forgot the name of class. Double check the name of the class again. Yeah. I think that's it though, you know, I don't really care about whatever. We didn't start that way, you know, so.
Yeah.
I'm not good at
When I was 20, 21, I wasn't.
Geometry.
something geometry, something, but I forgot it.
Differential. Water
I
use.
think it's easier.
Class for geometry, something.
Non-Euclidean,
Oh, non-Euclidean geometry,
non-Euclidean.
non-Euclidean.
We haven't even started geometry yet, no, we were just kind of goofing off. Like, I still don't know what the class is gonna do. But I acquired one.
So does it make sense?
Wait, but we thought this, he's not giving any tools.
Would have the bride somewhere on the left.
I'm just doing that, but we did
The other half would have the bride.
Yesterday, we
somewhere on
did do
the
a
right.
latex boot camp. Because a lot of
Oh,
stuff.
These are two individuals that would randomly
We
be
haven't
swapped into
gotten
the-
into the main content, like, we were doing
So
some
half the
geometry
time,
instructions.
the bride's gonna end up on the left.
It was,
Yeah, but
Half the time, the bride.
today, I think I
Right.
finally learned. I haven't learned it, it's been 3 days.
What's the other way to think about that? What's that?
I'm good, but like.
So, I don't know.
It's kind of more obvious.
Yeah. The other way to do it, the other way you could do it is you could literally go through and say, well, the bride has to be to the left of the groom, so let's write out. You could like list out every case of putting, you know, the bride somewhere to the left of the groom.
Yeah.
And you would get something like 15 of those. And so you'd have however many of those there were multiplied by the 8 choose 4 times 4 factorial for filling in the 4 blanks. So you could, this is sort of being a little more explicit, writing out all the cases. But if you want the clever answer, the clever answer is to say, oh, it's got to, by common sense, it has to be half of all of the pictures that have the vote. So, yeah, that's.
Did you have done it that way on the exam?
Oh, yeah, oh, yeah, I wouldn't have minded that, Yeah, I mean, we'll talk about it as the exams get closer, you'll have limited time. So, you know, I may make questions that create too much of a time crunch for a brute force thing, if I really want to force somebody to really have the right sort of more sophisticated reasoning. But yeah, that certainly would work. Yeah, so. Anyway, we're gonna get kicked out by the alarm bell here in a couple of minutes, I think, but is there? Okay.
But. Disengage, 15.
I think there are, because here's what you're doing here is.
Oh, yeah.
If you're-
Every time you see the group over, you add.
You add two.
Yeah, you're on the
Okay, and this is 15. Because this
I
is
just think those
6
divisions
times
by
5
two.
divided by.
Yeah,
That's like.
Yeah.
My signature?
There's 15 ways to choose.
It's kind of awesome.
Special plots for the bride.
It's so obvious.
And then we must put the bride
Oh, yeah.
on the, just 2 slots, we must always put the bride on the left side.
90% of groups follow me. I'm like, oh, there's super obvious like tricks.
So we don't have to make any more choices. From there. Yeah. Okay,
So,
great.
So like five, so there's 5 choices for the groom, this is how I was thinking that, right? 5 choices for the groom.
6 choices. There's 6 slots in.
Oh, I'm saying like, the groom has to be in one of these, the groom can't get or left one.
Oh, you're gonna do it that way. Okay, so you
That's what I was going by.
5 choices for where the groom goes, but here's the challenge with that, is that depending on which of those slots the groom chooses, the bride's choices will be affected by it.
Right,
So like, if I put the groom here, then the bride has no choices.
right.
If I put the groom here, the bride's got a couple of choices. So now you're kind of in a case where you can't just take the 5 choices of the groom and multiply them by all of the rest of the process. Instead, what you would have to do, I'm not gonna say it's not possible, but what you would be forced to do is cases. Where you say, yes, you would have a case, what if the groom is here, right? Another case, what if the groom is here?
Yeah.
And you add those up.
Right.
And each one of those would in itself take probably just as long as, you know, just getting one solution for the whole thing, which is to choose both slots that the bride and groom are gonna be occupying up front. You got 15 ways to do that. I've written out the first 3 here. Choose both of those slots. Then you must put the bride on the one that's on the left and the groom on the one that's on the right. And then deal with the other. So there's no choices for that. Once I've done the 15, then I must do B on the left of G. It's not like I can do G8, going one way to do that. So there's 15 ways to get that much of it done. And then the remaining choices involve those 4 empty slots. How many ways are there to take 8 other people and choose 4 of them to put in those 4 slots? And that's just gonna be 8 choose 4 times 4.
Okay. Okay. That's, yeah, thank you.
That's
Just someone confused me even more.
what I just said. Well, let me put to you this. When I'm putting this picture together, I wanna think of it as 2 things I have to do. I have to get my bride and groom into the picture, and then I have to get everybody else in. Okay, and those 2 things, I'm gonna multiply it. How many choices for the bridegroom, part of it, and how many choices for the rest of the picture? Okay. The bridegroom part of it is 15.
So where it's on the.
Where the bride's to the left of the groom, yes, I have 15 ways of choosing how I'm going to configure the bride to the left of the groom. There's this one, there's this one, there's this one, and there's 12 more. There's a total of 15 of those. For each one of those, I then now have the second part of the task, which is to come up with 4 more people to fill in the remaining 4 spots. And so that's where you take, well, there's 8 other people, you choose 4 of those. And that's only choosing, them. That's not putting them in order yet. They choose 4 ways to choose those other people that are going to actually participate in the photo. And then 4 factorial ways to actually put those 4 people into the 4 open spaces that are left. The bride and groom have already been put in here, so we don't have those spaces available anymore. But there's still 4 other spaces that are open. And we have to put the 4 people into those 4 spaces, and that's the 4 factorial. Yeah, so it would be 15, it would be 15 times 8 choose 4 times 4 factorial.
Okay. Yeah, cause I was trying to think of it the way you said for part B, where you just divide it by 2.
That's also, that's the clever way to do
And
it.
that was kind of confusing me.
Mhm.
And
Yeah, well, if you think of it that way. The first thing you do is you choose which 2 slots the bride and the groom are gonna stand in. And then you choose which order they're in, left, right versus right, left. Then you have the same 8 choose 4 times 4 factorial after that. So here you have this extra if I don't force the bride to be left to the left of the groom, I have this extra 2 factorial where I have to decide, is it the bride on the left of the groom or is it the groom on the left of the bride?
I see it.
Here, I don't have that choice. Because I'm forced, once I've chosen which slots the bride and groom are in, I must put the bride on the left one and I must put the groom on the right one.
Is that's just equal to 15 first.
Yes, 6 choose 2. Yeah, exactly.
And what time are your office hours today?
I'm gonna go outside right now because the fire alarm's gonna go off any second. I'm gonna be out by the fountain and as soon as the alarm is over, I'm gonna go straight to my office until 7. After 7, I'm gonna take a break, but I'll be back by 8:30. And 8:30, I'll stay until 10. Make sense? Okay, alright, see you later, guys. Yep, bye.